Hello everyone. Today we are going to discuss some programs on process synchronization. So we are going to cover two questions in this video. First one is very simple. You need to simulate deadlock between three threads. So if you have already seen the video where we discussed the creation of deadlock, if you have understood that, you should be able to do this very easily. Second one is a little tricky. So this is a star question for this particular lecture. You need to write a program to achieve synchronization between multiple threads. So there can be n number of threads. Okay, that depends upon the user. The threads try to acquire a resource that has two instances. There is only one resource. There are multiple threads, but there are two instances of that particular resource. So this means that at least two threads should be able to acquire the resource at any given time. So let us start with the first question, where we will try to simulate deadlock between three threads. So we have the header files that we require. Since we need to simulate the deadlock between three threads, so we will have three functions also. Let's suppose f1 star f1, then I'm just going to cut paste this. So f2 and f3. So we'll require three resources also. So pthread underscore mutex underscore t. So let's suppose that the resources are r1, r2 and r3. The main function, first thing is underscore mutex underscore init. So we need to initialize the first resource. Similarly, you can cut paste. So here you can write the second resource and the third resource. Now we need three threads. So t1, t2 and t3. Create t1 null, the first function, and again null. Cut paste for the second thread and the third thread. So functions and t2 and t3. Last step is join t1, cut paste t2 and t3. So this is the setup that we require. Now for the function f1, so what the first thread is going to do is pthread. So let's print t1 acquiring r1. Okay, so that's the first resource. How to acquire it? pthread underscore mutex underscore lock and r1. Again have a printf t1 acquired r1. Alright, after that go to sleep. So now what we can do is t1 can try to acquire r2, the second resource. So we can cut paste these three lines, uncut and again uncut. Okay, so t1 now will try to acquire r2 and r2. Okay, so that will be enough for the first function. So we can do this same thing for the other two functions also. Okay, so let's first do it for f2. So what thread 2 will do, thread 2 will first try to acquire r2, alright, and then t2 will try to acquire r3. So we are going to make a circular wait situation. t1 will get stuck for waiting for r2, t2 will get stuck for waiting for r3. Similarly, t3 will acquire r3 first, r3, and then it will try to acquire r1, t3 r1. Okay, one change here in function 2, here it should be r3. Okay, so this should do. Save it, compile q1.c minus lp thread, redefinition of f1. Okay, let us see what is the error. Okay, so I have not changed the function name. Here it should be f3. Okay, clear it once again, compile, fine, run it. Alright, so you can see that there is a situation of deadlock. T1 acquired R1, T2 acquired R2, T3 acquired R3, and then they get stuck when T1 tried to acquire R2, T2 trying to acquire R3, and T3 trying to acquire R1. So they get stuck in a circular wait situation. Now coming on to the second question. Write a program to achieve synchronization between multiple threads. So first thing that we are required to do here is we need to create multiple threads depending upon the user, how much the user wants. Then all those threads will try to acquire a resource which has two instances. So there are multiple instances of the same resource. How many instances? Two instances. So if two instances are there, this means at a time two threads should be able to acquire the resource. In one thread will be able to acquire one resource, one instance, and the second thread will be able to acquire the second instance. If there are more than two threads, like let's suppose there are three threads, so the third thread should wait for its chance. Means when one of the threads release one of the resource, then only the third thread should be able to acquire it. So this is what we are going to do. So these are the header files that we will require. So you can see there is one extra file, semaphore.h. If you remember in theory, if a resource is having multiple instances, then we need to make use of the concept of counting semaphores. Okay, so I'm going to solve this problem with the help of counting semaphores. So let's declare the function prototype. So we require only one function because each of the thread is going to acquire the same resource itself. Okay, so you need not to declare multiple functions for different threads. Then since we are going to use semaphores, so we need a variable of sem_t. Start the main function, initialize the semaphore variable. Now this is the key here to the entire program. Now here when we discuss this semaphore concept, I wrote here 1 because I told you that this value means what is the initial value of the semaphore variable, and it depends upon the number of instances. If we are using the concept of counting semaphores, this means this initial value should be equal to the number of instances available. So in this case there are two instances available, so the initial value should be 2. Okay, so this is the key concept in this particular program. So once you have it, now the first thing is I need to create n number of threads. So for that, let's take the input from the user, how many threads the user wants to create. So enter the number of threads, how many he wants. So scanf, save that input into the sum variable. So I will get the count, how many the user wants, then use pthread_t. So this is the variable. Since there is going to be a count, so we use array. Now start the for loop from 0 till I less than num I plus plus. So we will create those many threads. So then pthread_create. We just need to use a loop, that's it. Rest everything remains same. Thread, so it will be the ith thread. Okay, 1 per loop, function 1 function, sorry. And now what I'm going to pass is I'm going to pass the number of the thread to that particular thread. So whenever the thread is going to call this function, I am going to pass the number of the thread to the function to print, so that I know which thread is actually doing the work. So pass here ampersand. I don't pass null because I'm doing this just to print from each thread that which thread actually is running, so that we know what is happening or which thread is doing the processing. Okay, so once you do this, fine, no need to start this bracket, so because there is going to be just one statement, so we can omit that. So second for loop now will be for pthread underscore join. Okay, so same, and now you can use pthread underscore join. So we are going to join all the threads one by one again. Null. Okay, so this will help us to create the threads as per the user requirement. Now what the thread is, or all the threads are supposed to do in the function. So everyone is going to do the same thing. It's going to try to acquire the same resource. So first thing is I'm going to convert that input, that ampersand I. So it should not be actually here. I'm going to take it as the input here, so that I will be saved in X. So now by default this is of type void, so we need to convert it into integer because I want to print that value. So let's first typecast. So this is how you will do it, int star X. Okay, so I'll typecast into another integer n, then I will use n for printing. So what I'm going to do is sem underscore wait. So this is how we acquire the resource in Semaphore. So this you should know from the Semaphore video that I have already shared in the lab. So whichever process thread is able to acquire the instance, so we are going to print thread, then we print the number, so that we know which thread is actually has acquired the resource n. Okay, so that's why I have passed the variable I from the main function just for printing here. So then the thread will go to sleep, so that some other thread gets the chance for execution. So once it comes out of sleep, it is going to release the instance, so that if some other thread is waiting for acquiring the resource, it can do so. Printf. So after releasing, you can print that thread gain %t, print the number, finished, or release the resource, whatever you want. Okay, so that's it. So what we have done, we have created, first thing was this initialization of the semaphore variable. Last parameter should be 2 because there were 2 instances. Then you create a number of threads, and then in the function you use sem underscore wait to acquire the instance, and then you release using sem underscore post. Use of sleep, so that every other thread also gets a chance to execute. Save this. Let's see if there are any errors. Compile it. -lp thread. Okay, there is one scanf. Okay, that's strange. Okay, and not some num, typing mistake. All right, so now, so let's start with 3 threads. Okay, let's start with 2 threads. There are 2 instances, so both of these threads should be able to acquire one instance, so there should be actually no problem. Thread 1 acquired the resource, thread 2 acquired the resource, thread 1 finished, thread 2 finished, no problem at all. Now if I run it again and I give a higher number, let's suppose 3. So now you see thread 1 acquired the resource, thread 2 acquired the resource, but thread 3 is not able to acquire until one of them has finished. So once thread 1 has finished, then only thread 3 acquired the resource. So you can see here, at any given time, maximum number of threads which has acquired the resource is 2. First it was first and second, then it is second and third, then both have finished. Similarly, if you give any number, let's suppose 5, so you will analyze that Again, at any given point of time, maximum of 2 threads are acquiring the resource. You can see here 1 and 2. Once 1 has finished, then 3 acquired, then thread 2 finished, then 4 acquired, then thread 3 finished, and then thread 5 acquired the resource. Okay, so you can again modify the program. From 2 you can give, there are 3 number of instances, and you will see that here in the output 3 threads would be able to acquire the resource at the same time. So that were the solution for the 2 programs. In the next lab, I'm going to cover programs related to inter-process communication.